you. Yeah, okay. So yes, so I'm Nathan Richardson. I've been working at the University of York. I've been working on a tool, Aconite, which is trying to move towards generating Sirius-Based Graphical editors from an annotated metamodel. So during this talk, we're going to go over a running example, which is the project scheduling language, which we're going to use throughout the presentation to show how the diagrams and representations are being generated. We're going to have a quick look at the graphical representation, specifically having a quick look about why we need to be able to specify them specifically. We'll go over a targeted graphical modeling framework in Eclipse's Sirius. And then we'll have a quick look over the proposed tool, which is Aconite, and that will include a demo of the tool working, and then we'll have a quick look at the future work. So the project scheduling language is primarily focused on a project which is made up of a bunch of tasks, each of which can contain any number of deliverables, containing all of the people as well within the project, and this has a bunch of efforts which relate the tasks to the people and the percentage of their effort that they're going to put into that task. And also we have the fact that different tasks can depend on each other. So when we're doing graphical representations, the generic way of applying it, for example, whenever we're using object diagrams, that's a generic representation. Whenever we want to represent the model, we have to contain all of the information as we are using an untargeted diagram. This means that if you want to be able to visualize any particular interaction between any two elements, all the information needs to be in there. And this is a very inefficient syntax, and this also happens with, for example, effort, which in here is acting as an object the same as any other, whereas it's much more acting within the semantics of the model as a labeled edge. So what do? We use domain-specific representations. These are targeted representations containing only the required elements. They're manually defined, and they can have multiple representations containing all of the different subsets, and we can also see that we can represent, through the manual specification, them in the more semantically obvious way. So how do we do that? So one of the ways that this can be done is through Eclipse Sirius. It's an open source project which provides a model-based approach for graphical modeling. Yeah, and this can all be contained with multiple diagrams all being within the same artifact. This is counter to a previously popular technology in Eclipse GMF, which only supported a single diagram from a set of artifacts. It also has an interpreted it generates its representations through an interpreted manner, which means that you're able to tweak the model and immediately see the changes in the model that you are working on in the background. And this is unlike GMF, which required you to recompile and regenerate before being able to view the next model. And this was quite slow. So here at the bottom, there's just a quick link, which is to the gallery to show some of the industry uses of Sirius, because it is quite a common tool. So at a high level, Sirius is made up of three main concepts. These are the container, edge, and node mapping. These are contained often within the layer and the diagram. We're going to ignore them mainly for most of this talk. These can be contained within each other, so a container can contain other containers and nodes. It also does style representations. This is done through property views. These property views essentially just give you a way of editing all of the different properties in a way that makes sense, which you can see over here. And also the structure carries between the Sirius model and the spatial containment of the diagram. So here, if anything is contained within the container mapping, when we get to the representation, you will see that node or container spatially contained within its containment, as you can see down here. So one of the components of Sirius is the semantic candidate expressions. These are required for any domain-specific logic. For example, whenever you're trying to compute the elements that are shown within the diagram. So on the right here, we have an example of this. We're trying to contain all of the tasks from a project to then be able to represent them. And this is using a reference from the model. These are always required, and the users need to have some understanding of the metamodel because, as I just said, they are references. The domain class is also required, and all this does is filter the types to make sure that they are of the right type. And the understanding of the metamodel can become more complex if we have multiple layers of referencing, as it requires the user to understand the structure of the metamodel itself, not just look at each individual reference. So I'm just going to quickly go over some of the areas of Sirius that are targeted with Aconite. So one of those is the reuse. The reuse within Sirius has two options. You have reuse mapping, which just points that the container is going to contain another copy of this person node up here. We can also do it with import-specific nodes. These essentially are another class of nodes which overrides anything that is written within it, and otherwise it will defer to its essentially parent. Both of these require the original to exist. Another part of Sirius is the way it's persisted. This is done with an XMI. As you can see, it is quite complex, but obviously it's mainly designed for data transfer and not readability, although it is readable compared to, obviously, binary. This means that singular changes can sometimes be easy to see. Other changes produce much worse results, for example, here. And this is actually a really simple change, and we'll go over that a bit more in the later slides. So the proposed solution is based on Eugenia. This was designed to reduce the effort of using GMF by generating from an annotated metamodel. The strengths of this is it was a single artifact, which was a lot easier to maintain, and it provided useful defaults. This meant that if you're sticking within the bounds of normal diagram styling, you don't have to specify all of the different features if it is within the default. The limitations, which stemmed from GMF, was it only worked with one singular diagram at a time and only representations of direct references. So as we can see, Aconite takes from it. You can see the correlation between the two styles. So it is very Eugenia-esque. However, because it is in Sirius, which allows multiple diagrams, it also allows multiple diagrams, and it provides useful defaults targeted at Sirius, and this includes expressions. And so some of the key features of Aconite is we are using the same descriptors as Sirius originally had. The styling is integrated, and this isn't required, but you can integrate the styling into a single element. We're using inverted containment for all of our containment, and the automated indirect SCEs are being generated in the background, and that is on page 7 of the paper, if you want to take a look. So I'm going to quickly go through a demo to show you how it works. Okay, all good? Yes. So at the moment we have this basic shape of the Aconite. So the node has a name, a container, and a color, and a label expression. The label expression is pointing here at our attribute down here. We also have an edge, and this is following a very similar structure. It has the name, the color, and the container. This is generated and has pre-generated this. But what we're able to do is we can make any changes. So let's change this over to blue. Let's make sure to spell it right. And here we can regenerate. And because of the interpreted nature of Sirius, it automatically transfers over as soon as we have regenerated our own design, which I did by right-clicking and clicking here. So then we're able to show we're able to add more diagrams on top of this. So these new ones are very much following the same style. Here we have one that's hitting all of our defaults. So for example, the color is, it wants a light yellow, and that is the default. And it automatically defaults that the label expression should be name. And that is happening in the background. So this one is quite simple. And then here we have another one which is pretty much the same. The edge is actually inferring itself what it should be pointing at based on the class type here. And that is automatically going to pick up on this node, and even though it's in a different one. So we can regenerate. And And there we go. So we have the new diagram, which has been generated based on that specification. One of the important things about this one is the fact that this is the first time that we're going to get use of the automatically generated SCEs with a bit more complexity, which I will show here. So this has automatically generated the referencing to have the two levels of referencing rather than just the one, which it's gone through the process of selecting which one is the best one for that specific case. So we're now going to add in the third diagram, which was in our examples, but I didn't go over it too much. And essentially what we're doing is we're adding in a reference between the effort that is applied for a task. And for this one, we're very much reusing all of the nodes that we had previously. And this means this is done by adding in to this container just the other diagram for both of these and nothing else. Nothing else is needed for these, and it will automatically duplicate it in the O-design in the background. And then we have another type of edge, which here you have to actually specify the source and the target, unlike in all of our other edges, which it was automatically deciding the source and the target because of the reference-based edge. So we can show that. So yeah, so that's that diagram. And then finally, the final example is our other reuse. So now what we're going to do is we're going to take the project diagram and we're going to edit it so that each of the tasks within here is going to... Oh, yeah. Each of these tasks is going to contain its deliverables. This will then be able to show the user the indirect dependencies that are happening between the deliverables within the tasks. To do this, we actually now need a container rather than a node. So what we do is we pull out that descriptor into a new line. And what we're able to do is we're able to use the extend keyword, which essentially gets it to point at the previous node, and it will automatically copy over all of the properties and override any that are specified within this annotation. So here we have a new container, which is the project diagram, and then this one is the effort diagram. Down here we can see within the container for us is irrelevant of whether it's pointing up at a diagram or a container node, which means that we can just add in the new container for the deliverable, and this will automatically generate in the correct style. And it will now contain within it all of the things that are happening within the original style without having to copy it across, despite the fact that in the background there's quite a lot of different things happening. And also by having attached this by having this extend keyword, it means that we only have one place to ever change the styling so that we can keep our styling consistent between all of our different nodes and containers. So one of the other benefits of doing this is that versioning becomes a lot more consistent, as we now have a dedicated textual syntax, and the descriptors we use whenever possible are the same or a similar keyword. For example, if we're ever making something a little bit more specific, we try and keep the name as close to the original name as possible. And that is the actual change that was happening in our really complex one, and that isn't even all of the change. So yeah, in the future, we plan to do some usability studies around the time taken to create new diagrams and edit our existing models. Also, further development, we're planning on adding more flexible mechanisms for cross-referencing annotated elements. We're going to add refactoring support specifically around renaming, because if you think back to how the names were working, they might change. The container's name might change, and we want to be able to factor that in and be able to refactor down to all of its yeah, I can't remember the word for my head. On top of this, we plan to move to generating other notations. This might come in the form of Sirius, which supports other notations other than node edges. So this will include maybe tables or sequence diagrams, depending on what kind of thing we get asked for. And then let's not skip the slide. We also are looking into the possibility of generating plant UML from the same Aconite, annotated metamodels, so that this can be used from web-based editors. So that's everything. There's a link at the bottom. Any questions?
Thank you, Nathan, for the presentation. Questions?
Thank you very much for the very nice talk. It's a very useful work in the sense that defining the representation in Sirius is very painful. So having something for supporting this is very useful and welcome. I have actually two questions. The first one, a very quick one, is about your perspective. I was just wondering if there is no way of supporting more static analysis of what we define in terms of consistency. So, for example, checking that we have no recursive containment, so containing something which is already contained, and such kind of things, which is more or less feasible in Sirius directly because we have a tree-based representation of the different representations. But now it's textual, so maybe it's more open to do some error when we do this. So do you plan to have some support for doing static analysis or not?
So at the moment, there is already some static analysis happening in the background. The way that I was doing it for the demonstration was I was just copying them through. But if I had been typing it, you would have seen some yellow text come up, and there is some static analysis automatically happening in the background to make sure that there's no loops, as you said, and it's also checking that a name is there and it's got a container, and then the edges are contained within a diagram at some point. And yeah, that's all happening in the background. So yeah, there is more that needs adding to it. It does deal with a lot of the problems that you could create, but not all of them at the moment.
Okay. And my second question is, so basically the power of such kind of tools like Sirius is about the ability of handling and managing a big gap in between the concrete syntax and the abstract syntax. Mm-hmm. And if we look at Sirius, basically what we can directly do with Sirius is very naive mapping in between the concrete and abstract syntax. And most of the time in real world use cases, we need to defer this to what they call services, external services, which are basically Java code that do whatever you want. And I was just wondering, in your tool, can you refer to such kind of external services or not? I didn't see any example, but maybe you can already refer to an external code for doing this mapping.
Yeah, so the tool, whenever it there are specific property names that you can have which automatically fall back on the Sirius version, which means that I could put in SCE or semantic candidate expression, and that would automatically fall back down on Sirius. I haven't quite added in the ability to have an annotation that adds in the Java specification for the bottom of the Sirius O-design file, but all of the rest of the stuff is there for it to work. That just needs adding, and I don't think that if people, as you have, like said, "Oh, we really need this," it would get added reasonably quickly. It's just a small annotation. It's just where it goes is currently the design decision that hasn't been made. Thank you.
Yes, thank you for the nice talk. So it seems that you use XML to store the models, right?
Pardon?
You use... Hello? Okay. You use XML to store the models, is that correct? So would it be possible to utilize some of the query syntax from XML to define user transformations over these models?
So yeah, so that one of the possibilities, so back when it was Eugenia, there were polishing transformations. It's quite possible that we could add in a polishing transformation style thing to the tool, and that would be able to generate, like, edit the underlying model, essentially.
Thank you.
It's a very nice approach. I would like to know a bit more about the limitations of this approach.
So yeah, at the moment, it doesn't handle the Java expressions, which is one of the main limitations. The way it's currently handling tools is not fully fleshed out. There are a lot of tools, if I quickly open it up, that I can show you. There are a lot of tools that are actually being generated in the background. It wasn't part of this talk, but the way that the non-automatic tools work is currently very complicated, and that's why the future work is to add in more stuff about how you can reference specific annotations. And that's quite a large limitation at the moment, is the fact that the tools need a way of being specified, and that's going to take a little bit of working out, but it is part of the way there. It's just kind of pushing it through, and I needed to do the paper at the time, so yeah.
Okay, nice.